You're not required to, but if you have access to it and would like to follow along, we're currently in the OneNote file of Modal Node System, MNS Presentation 2253, OneNote Modal Distance Intervals Color, list of presentations on the right, which we plan on adding plenty more to shortly. Also noting, in this OneNote presentation, we'll spend all of our time on the music theory side of things, but we have another similarly numbered and named presentations where we actually build these tables in Excel, practicing Excel music theory and table visualization skills all at the same time. Remember, our overall objective is to maximize the use of color to better understand music theory in general, to better create tools such as our fretboard helping us to navigate the fretboard. This fretboard having the low or heavy E string, the one closest to the ceiling on top. We have colored the collection of 7 notes around the C major using our color system for the points, as opposed to the color system that we're going to look at this time, which is distance. So we have 2 primary color systems. When we look at the fretboard, for example, with the points as a color system, we could tie the color to each of the 12 notes, each of those notes now being able to be defined, described by a particular color. And then if I moved from the collection of notes around the key of C to the 7-note collection around the key of D, the node has now moved up from the Ionian for the C to the D, but the colors are the same for each of the notes, helping us to practice each of those note colors. However, we could also use a color system like the Nashville number system, which is tied, instead of to notes, to the relative positions, in essence using the color system for the key of C major as a key or the basis on which we'll have all other 12 collections of 7 notes. So here we have the Ionian is green again. If we look at this shape, which I would call shape number 1, or a G-shaped C chord from the perspective of a caged system, and I move the whole thing up here, now we can see that the whole system moved up, meaning this red moved up here, and now the color has the same basic shape and distances between them, which is great. So we can also, however, map out the fretboard by distance. Now note that if I map out the fretboard by distance, then we have the same collection of 7 notes could have a distance relative to each of the notes in the 7-note collection. And in essence, that's how we build our chords. So in that case, we could map it out on one fretboard and map out all of the distances as they are compared to one of the nodes. Or possibly we try to put both on the same fretboard by, in essence, increasing the size of the fretboard. So now fret 5 has 2 sides to it, the position side and then the interval side. So the second side, as you can see here, is tied to the perspective of the Ionian node, meaning this C is obviously 0 distance from itself, or a perfect first. And then if I go from this C to this D, then that's going to be what we call a major second, or I'd like to call it 2 notes away from the Ionian node, first modal half step, meaning we went 1 step up. And then from a scale degree, it would be a second or a major second. So then if I want to change the perspective to the D here and say build a chord around the key of D, we can use the same color system for the points, not tied to the notes, but rather tied to the relative positions, and we'll get the same collection of notes. They haven't changed. That color system's not going to change, but the color system for the distance will change. So now you can see this Ionian, which was next to the C or on the 8th fret, is now next to the D, and the Dorian, which is on the 5th fret. And now all of the second halves of the fretboards are giving me the distance from the Dorian node. This is a very useful tool that we can create in Excel. And now you can create it in a database program, do it however you want to create it, but we can also use a color system to map out the colors. Now I know this two-tone color gets a little bit overwhelming, but actually once you get used to it, it makes sense because the color system is actually more clear than our naming conventions oftentimes in conventional music theory, because we have at least like 2 names and oftentimes like 3 to 4 names for the same distance. Meaning if something is a 4-note away distance, for example, we might say that that's going to be 4 notes away. We might say that it's 2 whole steps away. We might say that it's a 4-note away major third, for example. Well, the distance is the same in baseline half-step units. So if you just assign a color to the baseline units, then that's a functional way to see it. It's actually easier to see. And again, it gives us another dimension to be able to visualize things. So that's what we're going to do. We're going to look at the intervals and map out our colors. Let's give a quick recap of the color system for the points, however. So the points could be the notes themselves or the relative scale positions. So if I have an A, which is a 1, it's red. A 2 is an A sharp or B flat, it's orange. A 3 is a B, it's going to be yellow. And then the 4 is a C, it's going to be yellow green. And that's the one that we're also going to use as a permanent system, similar to a Nashville number system on the number side of things, to apply to all 12 collections of 7 notes, so that if I then have the 12 collection, the 7 note collection around the A major, then I would make the A green, right, instead of red. Okay, so I could make it red or green. I find it more useful oftentimes for most people to use a permanent system for relative positions as they move through all 12 collections of 7 notes most of the time. But both are useful. 5 is going to be C sharp or D, that's going to be green, and then 6 is going to, or D flat, 6 is going to be D, which is spring green. And once again, if I go a whole step up from the C, that's going to be in the collection of notes around the C major. Therefore, we're going to call that spring green the Dorian color. So D is going to be the 2, it's going to be the Dorian. Here's the symbology of just the D. The 7 is going to be D sharp or E flat, cayenne. And then we've got 8 is E, that's going to be sky blue. If I go formula whole, that E then is in our 7-note collection around the C major. It's going to be the 3rd of the collection of notes, which means it's going to be the Phrygian. So it's the 3rd Phrygian, there's the symbol sky blue. 9 is going to be F, that's going to be blue. Lydian, so that's going to be whole, half. So that means it's the 4th, 1, 2, 3, 4. So it's the 4th of our collection of notes from a Nashville number system, a permanent system. It's going to be the Lydian. There's the symbol for it. Then the 10 is going to be F sharp or G flat. That's going to be violet. And then the 11 is G. That's magenta. If I look at the formula, whole, half, whole. So that's going to be once again in our 7-note collection, the 5th of the 7-note collection. It's always going to be a permanent number 5, Mixolydian. And so Mixolydian is going to be magenta. 12 is G sharp or A flat. That's going to be rose. And then we go to 13, which is equivalent to the A. We've gone around in a circle. So that's going to be then once again in our collection of notes. So we went whole, half, whole. Red, therefore, is going to be the 6 from a modal standpoint. It's the Aeolian node. There's our symbol A, and then we go around to the 2, which is A sharp or B flat, and then the B is the last in our collection of notes, equivalent to this yellow up top. So that's going to be the 7 in our collection of 7 notes, which again, this color system will be the same in any of the 12 collections of 7 notes if I just apply the same formula to any of the 12 notes, and instead of using the note colors, we use this color system as our key. All right, that's one color system. All right, and then I'm going to go over here and say we have the distance color system. So all we did is take the color wheel, rotate it 15 degrees so that we have a similar color system but different names, so that I can actually name the full distance by point to point, the modal range. I went from this color to that color, and I can name the distance in color using a different color system, right? So in other words, if I don't go anywhere, I went from the Ionian node to the Ionian node, or C to C, I'm going to call that orange flame. It's similar to red if you can visualize the color spectrum, at least how it is from a color standpoint, because it's kind of different from physics. It's kind of the other way around, but we're going to say it starts at red. So this, you can see, is not exactly red. It's going to be, because it's 15 degrees up from red from our 360-degree wheel. So then if I go one step up, distance-wise, 1/2 step up, I don't care what you call it, a half step or a 1 node away minor second, it's going to be amber. If you go 2 steps up, I don't care if you call it 2 steps up, 2 half steps, a whole step, or a 2 node away major second, it's going to be chartreuse. If you go 3 steps up, I don't care if you call it 3 steps up, a whole step and a half step, or you call it a minor third, it's going to be lime. 4 steps up, I don't care if you call it a major third, 2 whole steps, 4 half steps, it's going to be mint. If you go 5 steps up, it's going to be aqua. 6 steps up, it's electric sky. 7 steps up, I'm just going to call it azure. 8 steps up is grape. I'm just going to call it instead of ultraviolet. 9 steps up is orchid. 10 steps up is fuchsia amber. And finally, 11, I'm going to call it punch. All right, then if you go 12 steps up, you could then say that we're going around the circle. So we visualize our steps up as either we're going around a track, like a race car track, or a running track, in which case we end up at the same spot, which would just be a local distance of orange flame. Or we think of it more like a note number line, where you're going to the right and you just keep on going to the right, right? So that means it's going to be 12 up. So it's going to be orange flame, but an octave lighter or shade lighter. If you go 13 up from a circle, you went around the circle and then 1. So it has a local distance 13 minus 12, which is 1. Or from a note number line, you went a distance of 13 to the right, which is going to be once again amber, but a shade lighter. 14 up would be either you went around the circle and then an added 2, 14 minus 12, or you went on a note number line to the right, which would be chartreuse, a shade lighter. Similarly, if you go backwards 1 note, then that would be like going counterclockwise on the circle. The normal way to go around the circle, that you don't get hit by the other cars that we're imagining on our racetrack, is you go to the right. You're breaking the rules going backwards. But so that would be equivalent to the local distance of going 11 forward, which is punch. So 1 backwards is also going to be punch if you think about it from a local distance standpoint. But if you think about it from just going around the circle, normally going around clockwise. But if you think about it as a number line, you went 1 step backwards, and that's going to be a shade darker. 2 step backwards or counterclockwise would be equivalent to 10 steps forward. So it's going to have the same fuchsia, but it's going to be a shade darker if we want to take into account the octave lower. 3 steps backwards would be like going 9 steps forward. 9 steps forward is the normal way or local distance. Therefore, if I go counterclockwise, I'm going to call it orchid, but it's going to be a shade darker if I want to take into consideration the octave lower, and so on. So these are the distances that we want to then use to define, in essence, intervals. So intervals become our distance naming convention.